Hi guys, this is Ms. Miner, and this is assignment 4B, Unit 4, Assignment B, and we are going to be working on finding the slope from 2 points, from a table, and from an equation. And so we're still going to be working with this guy right here, okay, our favorite. And we learned last time that the slope, the variable we used to represent slope, was m, and that slope is its math name, right? Like that's what we've been calling this here is per, right? We've looked for the words each. And so from a story problem, that is what I look for, right? But in math, what it's really called is, we learned slope, this number, and we use the variable m to represent the slope in the equation. That's what we started talking about last time. We learned how to find it from a graph. We talked about rise over run. That's another really good thing to put here, rise over run. And so we're going to stay kind of right in this lane. Today we're going to be looking at points. Remember our ordered pairs where we have an x and a y value. We want to be able to find the slope from a pair of points, and from a table when we have x and y values on a table. You've seen these before. Something like that. And then also from our equation, where is our slope found in our equation? You should already maybe know this one. We've kind of talked about that a little bit just now. Okay, so we're going to kind of cover that again. All right, let's do it. Finding slope from a table, an equation, and from points. And this is going to be kind of the notes that we're working from. I'm going to skip ahead just a little bit. I think I know where I want to go from this, but it's been a while since I taught this, so I want to make sure that I'm going in the right direction here. Okay, so finding slope from a table, an equation, and from points. Here is where we're going to start. We're kind of going to give some steps, and then we're just going to do some practice. So here's some steps that you can follow in order to get slope from a table, from 2 points, and from an equation. Okay, we're going to start right here on the left-hand side where it says finding slope from a table, and you can fill in your notes as we go along. The very first thing that it says is, I'm going to just pick this here. Step 1, pick 2 points off of the table. Now remember, a point on a graph is an x and a y value. So I need to choose a couple of these. So I need an x and a y value. So I'm going to choose that one, and then I'm going to choose this one that's right underneath it. We could choose any two, so pick the ones you like the best. I'm just going to pick the top two. And then it says step 2, find the change in your y values. So what I'm going to do is I'm going to look at this graph, and I'm going to say, okay, my y value started at 10 and went to 8. So how much did it change? What happened there? Well, it went down by 2. If I take 10 and I minus 2 from it, I get 8, right? And so the change was I subtracted 2, or I went down by a value of 2. So I'm going to write that in the box right there. What was the change in my y values? Then I'm going to do the very next thing. I'm going to decide what was the change, but this time in my x values. I'm going to look at my table, and I'm going to say, okay, my x value started at 5 and went to 8. I'm going to erase my star here so I have some room. So what changed, right? It went up by 3, or I added 3. 5 plus 3 gives me the 8. So I went up by 3. The next thing that I want to do in order to find the slope is I want to put the rise over the run. Well, if I'm looking at a graph, right, let's just use this graph as an illustration. My rise is the y-axis part. The y-axis is the up and down, or the vertical axis. And so if I want to know my rise, then I have to look at my y values. How much did this go up? Well, it didn't really go up on this one. It went down by 2, right? And so my rise was down 2 or -2. And then I do the exact same thing. My run, if I look at my graph, my run, or my right and left movement, is my x values. And so I take my x values, I take my rise, and we can label this. That was my y values. And I put it over my run, which was 3. Rise over run. So I'm looking for exactly the same thing that I was looking for from a graph. I'm just getting it from the table instead. And that's my slope. So pretty easy to do. Okay, let's just remind ourselves how we got it from a graph, just in case we, where this rise and run came from, right? Remember, on a graph, the first thing that I have to do is find 2 points on the graph. And we're talking good points that go right through an x value. So I kind of follow this red line down until I find some good points on my graph. There's a few, right? I only need to pick 2 of those. Once I've got some good points on my graph, I only need to pick 2. And then I draw in my rise and run. Remember, the slope is the change in height and width, or a ratio of height to width. And on a graph, we call that the rise and the run. And the rise here was 2. And the run here was 1, 2, 3, 4. So on this graph that we're working on, then remember, okay, so I draw a step up and over between the 2 dots. We did that. That was my black line. And then we counted how tall. It was 2. We counted how wide. It was, sorry, not on this one. It was 2. And then it was 3. It was 4 wide. Oh, erase. And then we put the rise over the run. We said this one was 2/4. But remember last time we said we had to do a 6th step? And step 6 was check if my line, is positive or negative. And that means, is it going up or down? And if I look at this graph from left to right, it goes down, and so I need to make that be a negative. And then the last thing I do is simplify. So this one was a -1/2 slope here. And remember, the ratio of rise over run, or how tall the slope is versus how wide the slope is, that tells me its steepness. And slope is a ratio of height and width. We call it rise and run on a graph. And that tells us the steepness of the line. Okay, so that was a review from last time. And that's also kind of gets us back in the mindset of where rise over run comes from. It's that ratio of height to width. And so this, when we look at it from a table, we're just figuring out, that ratio of height to width. And lastly, we wanted to figure out where to get it from an equation. Well, we've already kind of identified, right, even in Unit 3, that number in front of x, the coefficient, if you will, of x in my equation is my slope. So if I find where the x is, then I just look at the number that's before it, and that's my slope. The most important part of this is going to be getting this equation in the right form, right? If my equation is not solved for y, then I need to get y alone. And so we'll take a look at a couple of example problems where we have to do that first. So make that one note important to you. It already has a star by it, but maybe you could circle it and just remind yourself that when I'm looking at my equation, I have to have it in what we call slope-intercept form, which is y equals blank x plus blank, the form that we've been using, the form that we're familiar with. If it's not solved for y, I need to get y alone. I need to solve for y first. And then lastly, let's find the slope from 2 points. Well, guess what? 2 points are just a value for x and a value for y. If I have an ordered pair, it is the same idea as solving a table, right? It's just I gave you the 2 points instead of you got to choose them off the table. So the idea here is exactly the same. And so all I have to do is put my 2 points in an xy table. And so x was -2, y was 3, x was 1, y was -2. And then I do the exact same steps that I did over here. I find the change in my y values. So over here, it started at, and now I'm, let me see if I can move this over just a little bit here. There we go. Now I'll have enough room. I'll kind of do some erasing, and then I'll have enough room that I can, there we go. Okay. So we had 3 here and -2. I'll fix that. Okay. I started in my y value at +3 and went to -2. So how much did that change? Well, if this is a -2 right here, remember I have to go from 3 all the way to 0, which would be 3, right? And then from 0 to -2. So I went down by a total of 5. I went down by 5. I'm going to have to move that over even farther just to give myself enough room. Here, let's do this. Let's kind of make it up here. X, Y. This was -2. This was 3. This was 1 and -2. And hopefully now I have enough space. We said this was -5. Okay. Then over on this side, so first I find my change in my y values. That was -5. Then I find the change in my x values. So I look over here and I say it started at -2 and went all the way to +1. So -2 to 0 would be 2, plus 1 more would be 3. It changed by 3. It increased by 3. And you can check your work. Remember, I can check here. If I have 3 and I -5, I should get -2, right? If I, well, let me erase my marks here. If I have -2 and I add 3, I should get 1 down here. So I can check to make sure that I've figured out the distance there, or the change, the amount of change there, by just adding those together and checking to see if I get my next number. Okay, then I put the rise. Remember, the rise is my y value because my y-axis is the axis that goes up and down. So I put my rise over my run, and my rise was -5. I put it over 3. There's my slope. So I can very easily find the slope from 2 points. All right. Let's just practice this a little bit. Let's practice finding the slope from a table. So make sure you use your notes. I'm going to split screen this really quick so we can kind of use our notes, and I'll show you how to use your notes in order to do these things on your assignment today. So on my notes, the first step is pick 2 points. So I have a table, and I'm looking at from a table in my notes, and it says the first thing I want to do is pick 2 points. And so it's up to you what you want to do. You could circle them, or you could just kind of like highlight them. Oh my goodness. Go back there. Whatever. You could highlight them if you have a highlighter, or you could underline them. You're just going to pick 2 of those, and you're going to say, okay, what is the change in my y values? So the step 2, find the change in your y values. In my y values, it started at 10. My y value started at 10 and went up to 4. So it increased by 4. And remember, I can check my work here by just taking my first number. If I add 4 to it, do I get my second number? And yes, I do. Okay, so I'm just finding that change. What changed? Well, from 10, I added 4 to get to 14. And then I do exactly the same thing over here with my x values. I started at -2 and I got to -4. So I needed to subtract 2 or go down by 2 in order to get to -4. Then it says put the rise, or in step 4 over here, it says put the rise over the run. The y value is my axis that represents the rise, my y values. And so the rise, or the amount that I went up, was 4. So the rise over the run, right? The rise was 4. The run was -2. And then I always want to simplify. This might be a good place to put a little star or circle it to make sure that I don't forget to simplify, because if I have a fraction over here that reduces, I always want to reduce it. And so this is going to be 2 over 1, or again, I can reduce again and just get -2. And so my slope here, if I were going to fill this into my equation, my slope would be y equals -2x. And remember, we're going to talk about this number, our phi number, if you will, later on in this unit. For right now, we're just focusing on getting the slope. And so the slope in my equation would be -2. Okay. Let's do another practice problem. Here's a table. Maybe a good idea for this one would be to pause the video and try and find the slope of this table on your own in your notes. So pause the video for a second and try and find the slope from this table on your own. Okay, hopefully you tried it on your own. The first thing that we're going to do is we're going to pick 2 points off of our table. You know what? Let's do something crazy here. Let's pick 2 different points this time. Instead of just picking the first 2, let's pick 2 different points this time. Let's pick this first point up here and this last point down here and see if it will still give us the right slope that we're looking for. And so what I'm doing here is now I'm choosing these 2 different points instead. Let's see if we can get the slope from these 2. And here's the thing, I just get to choose which ones I want to use. On a table, I can choose any 2. It won't make a difference. Okay, so to get from 3 to 7, I had to add 4. To get from 1 to 3, I had to add 2. So now, remember, the first thing I do is find the change in my y values, then I find the change in my x values, then I put my rise over my run. And remember, on a graph, my y-axis is the rising up part of my graph. My x-axis is the running part of the graph, or the left to right part of the graph. And so my change in my y value here, right here, represents how much my graph rose up. And my change in my x value over here represents how much it ran over. And so I just used the rise, which was 4, over the run. There's my ratio. And the last thing I always want to do is simplify. And so I'm going to simplify this. 4 divided by 2 is just 2. And so my slope in my equation this time would just be a positive 2. If I use different points from my table, do I still get the same thing? Let's go back to our original thought here, and let's just use these 2 points here on the table and see what we get. From 3 to 5, I increased by 2. From 1 to 2, I increased by 1. If I use that rise over that run, I still get the same slope. So you can kind of start to see that it doesn't really matter which 2 points I choose off of my table. Okay, what if I have 2 points? Let's find the slope from 2 points. Okay, so over here on my table, in my notes, the first thing that I want to do when I have 2 points is put both points in an XY table. So I like to label my points, X and Y, so I know exactly what I've got. And then I just draw a little XY table for myself, and I write my points in the table. So X value for my first point was 3, Y value was 0. X value was -2, Y value was 5. once I have my 2 points on a table, I just go ahead and do the same steps that we were doing before. I find the change in my y values. So from 0 to 5, I increased by 5. And from 3 to -2, I decreased by 5. Now remember, I can check my work. If you're unsure here, maybe you didn't get the same thing that I got. 3 minus 5 should give me -2 over here. So that kind of is the way that I check to make sure that I've got the correct change in my y values. Because sometimes it can be hard to kind of think your way through going from a positive to a negative number, how many that is. So you can use your calculator to help you check that. All right, then the next thing that I do, remember, is I put my rise over my run. How much did I rise up? Well, I ran up by 5. How much did I run over? Well, I ran over -5. And then the last thing I want to do is simplify. 5 divided by -5 is just -1. And so my slope would be -1. Try some of these other points that are here in your notes. Pause the video. I'll probably do at least one more of these, but you can check your work and see how you did. Okay, hopefully you paused the video and tried a couple of these points. I'm going to do one more for you. Here's an x value, here's a y value, here's an x value, here's a y value. X, y. All right, so x is 4, y is -3, and I just put it on my table. X is 3, y is -3. And then I go ahead and find the change in the y values. So change in the y values here, well, 0. I started at -3, I ended at -3, there was no change there. And that's okay, sometimes that happens. From 4 to 3, that was a change of -1. I went down by 1. And so my rise was 0. My run was -1. And so when I go to reduce this, remember this is rise over the run. So now I put the rise over the run, and then my 0 divided by -1, my slope would be 0. Think back to yesterday when we were talking about what kinds of slope, what kinds of lines we get from certain slopes. What kind of a line did I get when I had a 0 slope, right? What was happening there? If you remember, a horizontal line has a slope of 0. And so any line that's flat, right, is not increasing or decreasing. Anything that's flat, any kind of line that's flat, is going to have a 0 slope. So there is an example of what you might see in order to get a horizontal line. My slope will be 0. What's my next one? I feel like we can skip over that. Let's do some equations. That is slope from a graph. We're going to skip over for just now for the interest of time. That's just a review of what we did last time. And so let's move ahead. I'm going to go back to our big board here. And let's find slope from equations. Y equals blank x plus blank. This first box that was our per box. Now we know it is slope, and we use the variable m to represent slope. But now we know that the number that is paired with the x, we kind of just look at the equation, we find the number that is in front of the x, that is our slope. So if I'm looking at this equation here, we'll call this number 1. What I do is I find my x variable. What number is paired here? How many x's do I have? Well, in this case, I have -1. So my slope, or my m value, is -1. That one was super duper easy. Okay, let's go to number 2 over here. Let's call this one number 2 over here. Pause the video and try and find your slope from this equation. Hopefully you paused your video. What I do is I can see that this equation is solved for y. It's just backwards, but it still works. I look for the number that is paired with my x, and so that number is 2. My slope in this equation is 2. Another one that's super duper easy. Okay, next, pause the video, try and find the slope in number 3. Okay, hopefully you paused the video. You tried to find the slope from, if you said 3, I'm so sorry. What you're looking for here, remember, the very first thing that I have to do, and let's go back in our notes. Let me just go back a couple of screens here to our notes. And then I'm going to split screen. I'm going to bring our notes back here. We're going to skip over some of these. I'm going to bring our notes back here. And remember, let's just clean this up just a little bit. Remember, the number one thing that we have to do here is get y alone. That's the very first thing that we want to do in our equation. And so I have to look and I have to say, is y alone? And in this equation, it's not. And so I need to get rid of this number that's connected to my y. So I need to divide both sides by 2. I'm going to divide everything over here. Remember at the beginning when we were solving literal equations and we had to get y alone? Well, this is just review from, I believe it was unit 2, where we solved literal equations. We got y alone. So, I'm sorry, I divided everything by 3. I don't know why I did that. I should be dividing by 2 because I want to cancel out that 2 and get y by itself. And over here, 3x over 2, we can't divide that, so we just leave it, plus 5. 10 divided by 2 is 5. So there's my equation. Now I can look for my slope. Once y is alone, I can look for my slope right here. The number that's paired with my x value is the 3/2. So that is my slope for this equation. Okay, last one. Number 4, let's work through this one together. This is another one where we have to solve. And so let's remind ourselves how to solve and get y by itself. The first thing that I want to do is, here's my y. I have to get rid of any extra x's that I have. Remember, my rules for solving equations don't change. If I have any other variables in my equation, I got to get rid of those first. And so this is always an add or a subtract step. So I'm going to subtract 3 x's from both sides. This one is going to cancel out. And I'm going to have 5y is equal to 15 minus 3x. Okay, remember over here on this side I can't combine those two. And so I have to leave them separate. I leave them separate down here. They cannot be combined because the x term is not the same as having a plain number. They're different relatives, if you will. Okay, then the last thing that I want to do again is get rid of the number that's attached to my y. This is where I use divide. This is the time when I use divide. And that's going to cancel my 5 in front of my y. And so I'm just going to have y equals 15 divided by 5 is 3. And negative 3x divided by 5, I can't do that. That gives me a decimal, and I don't want a decimal, so I just leave it as a fraction. And once I get to here, and y is by itself. Oops, sorry, I thought I had a highlighter there. Y is all by itself. Then I can look for my x term, right? There it is. And the number that's connected to my x. Now, you guys, the number that's connected to my x, negative 3 over 5, that's my slope. Oh, let's say equals m. Negative 3 over 5 equals m. There's my slope. So that's from an equation. Here is a whole bunch of practice. And the one that we probably need to practice with is this graph down here, number 9. What is the slope of a vertical line? The slope of a vertical line, remember, we talked about this in our notes, is undefined. Let's talk about why it's undefined. Let's just use our steps for finding the slope from a graph to figure out why we say we can't mathematically calculate this. This is undefined in math. And so up here, we have 2 points, okay? And if I try and draw a run, right, there is no run. There's only rise. So the rise, right, in this graph between these 2 points, let's count it up, the graph is 1, 2, 3, 4, 5. So the rise is 5. The run, there isn't any run. It's 0. And if I put in my calculator 5 divided by 0, what do you get? Pause the video, put that in your calculator, see what you get. Well, if you remember from 3rd grade math, hopefully you pause the video. You can check your work, or what happens is we get an error message. It says we cannot do that. If you remember from when you were learning your division problems back in the 3rd grade, anything that is divided by 0, I cannot calculate. I can't take 5 items and divide them equally into 0 groups. That doesn't work, right? Just the 5 items is one group. So there's no way to divide things into 0 groups. That doesn't exist. That's not mathematically calculated. And so in this case, when my run is 0, then we say that the slope is undefined because we cannot calculate a number on top divided by a 0 on bottom. That just doesn't, that's not a mathematical problem that we can actually calculate. So we say it's undefined. All right, so hopefully you have kind of gotten some practice here. If you need some extra practice or you need some extra help, please email me or Mrs. Zeider, and we can work with you to get a Google Meet set up or meet with you at the school in order to get you some additional help finding slope. Use some of these extra practice problems in your notes in order to, make sure that you know what you're doing, and then remember that you can always email us if you have any questions. Okay, thanks guys. Good luck.